For day 2 of lesson 4, we're going to look at how we can divide using scientific notation. Yesterday we worked on multiplying. Today we're going to work on dividing. So what we need to do is start off with our first two factors. Our first two factors in this situation are the first two numbers. So we need to start off by taking 9.4325, and we need to divide it by the second factor in the second scientific notation. In this case is 3.85. When you divide those two numbers, you get an answer of 2 4500ths. Now this is going to have an answer that's in scientific notation, so it's going to be times 10 to some power. As you recall, when we divide with fractions or divide with exponents that have the same base, we subtract. So we're going to subtract 27 minus 24, and that gives us 3. So our scientific notation is going to be 3. So we have 2.45 times 10 to the third. Whenever we divide with scientific notation, we always need to keep in mind LARS. So we're going to do left you add, right you subtract. So on this next one, if this is what I'm given, 14.86 times 10 to the 11th, I know this is not scientific notation. I would have to move my decimal one spot to the left, and because I moved it one spot to the left, I would have to add 1 to my exponent. So I would have an answer of 1.486 times 10 to the 12th power. On this second example, I have something that's also not in scientific notation. I would have to move my decimal 1, 2, 3, 4 spots to the right, and when we follow LARS, left you add and right you subtract. So we moved it 4 spots to the right, we have to subtract 4. So now we would have 4.2 times 11 minus 4 is going to give us 7. So we have 10 to the 7th power. So keep in mind LARS, left you add, right you subtract. Now in our example 2, we're going to follow the same process. We're going to do 4.85 divided by 1.25. You get an answer of 3.88, and then we subtract our exponent. So 14 minus 9 is 5, so times 10 to the 5th. Look at that. Make sure you have one digit to the left of the decimal, and it's written in scientific notation, so you are good. Example 3. You're going to do 1.85 divided by 6.25. You get an answer of 0.296, and we have to have times 10 to some power. You're going to do 22 minus 17 gives you a power of 5. Look at this. Is it in scientific notation? Is there one digit to the left of the decimal? There is, but it's 0, and 0 doesn't count, so we have to move it one spot to the right. So we have 2.96. If we move it to the right, we subtract 1, so times 10 to the 4th power. Take a look at example 4. We have 3.003 divided by 9.24 results in decimal point 325. Subtract your exponents. 7 minus 2 is 5, so 10 to the 5th power. Just as a reminder, you divide those numbers. That's where we get the decimal point 325. You subtract your exponents, so 7 minus 2 gives me 5, and that's where my exponent of 5 comes from. Now ask yourself, is this in scientific notation? No, we have to move the decimal one spot to the right. So now we have 3.25. When we move it to the right, we subtract. We moved it one spot, so subtract 1. So then it would be times 10 to the 4th power, and you're finished. Example 5. 9.9 divided by 1.1 is 9. 10 to the 5th and 10 to the 2nd, so we subtract. We get times 10 to the 3rd because 5 minus 2 is 3. Now, because I had a whole number of 9, if I did have a decimal, my decimal would be after the 9. So is this in scientific notation? Is there one digit to the left of the decimal? Yes, there is. So your answer is in scientific notation. I would like for you to pause it here, try example 6 on your own, and then hit play again. If you solved it and this is your answer, you are very, very close, but you need to ask yourself, does my answer have one digit to the left of the decimal? And my answer would be no, because 0 doesn't count. Now, how did I get this? I took 2.04 and divided it by 6.25. That's where I got this. I took 13 and I did 13 minus 3, and that's where I got the 10. So now I need to write it in scientific notation. I need to move it one spot to the left. And if I move it one spot to, I'm sorry, I said left, but it's actually right. Moved it one spot to the right, so I subtract 1. So I have 3.264 times 10 to the 9th as my final answer. Last example, we have a country has a population of 1.35 times 10 to the 7th. If the country has an area of 5.4 times 10 to the 4th square miles, find the population density of the country. So what we need to do is we need to take our first scientific notation, which is 1.35 times 10 to the 7th, and we need to divide it by 5.4 times 10 to the 4th. So now go ahead and start off by dividing your first factors. When you divide your first factors, you should get 25/100ths, 0.25. Subtract your exponents, so 7 minus 4 is 3, so we have times 10 to the 3rd power. Now this is not in scientific notation. We need to move our decimal one spot to the right, and if we move it to the right, we subtract 1. So our final answer would be 2.5 times 10 to the 2nd power, which means that we have 2.5 times 10 to the 2nd power number of people per square mile. Well, what would that look like in standard notation? How many people is that per square mile? Well, times 10 to the 2nd power means times 100. So 2.5 times 100 would be 2.5, move it 2 spots to the right, that'd be 250 people per square mile. Please see me for your homework for this lesson, and when you're finished, check in with me before you move on to the next video.